This is Josh White with JW Math Tutoring. In today's video, I'm going to go through Bluebook practice test number 11, Math section Module 2B, the harder of the 2-second modules. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Before I start going through the explanations to the problems on this Bluebook practice test number 11, module 2B, the harder of the 2-second modules, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, be sure to check out the full solutions and explanations to module 1 and also module 2A, the easier of the 2-second modules for this same practice test number 11. And additionally, I made a separate video that covered Module 1 and this same Module 2B that I'm going to go over now, where I basically did a first look. So in other words, I worked through those two modules for basically the first time, not having seen any of the problems in advance. So if you want some more information on the timing, and how to approach that, complete each section under the 35 minutes, please check out that video as well. And related to timing, this video will most likely go past the allotted 35 minutes because on some problems I will show 2 or possibly even 3 different methods to solve them. So just be aware, during the test you would not be required to do that. You would only do that if you had extra time left over at the end and wanted to check an answer, which I did end up doing that on several problems in that first look video. Alright, so I think that should be it. Let's go ahead and get started. Bluebook practice test number 11, math, module 2B, the harder of the 2-second modules. Question number 1. Here, Josie has basically paid $19.50 so far, and then she purchased 10 identically priced stickers. And the total for this pass and for the stickers, $62. What was the cost of one sticker? All right, so your basic equation that you're looking at, right, is just 1950 plus 10 times x equals $62. Now, you can solve this however you want. You could solve it by hand. You can just go to Desmos and basically type in the equation as it's written, and then look for the vertical line right here. It's at 4.25, and that is the correct answer. It's letter B. You could technically do it using regression, which I'll do on some of the later questions. And you also technically could back solve this, meaning you could start with the answer choices. Like maybe you start with answer choice A, and you basically say, okay, it's 1950 plus 10 times, let's say they're 195 each. Does that equal 62? No. Okay, let's go check the next one. Okay, that equals 62, so that just confirms that it's B. But that's another valid approach you could take as well. All right, next up, question number 2. Here you have a system of equations. Before I go to Desmos to solve it, I will just show you the possibly quicker way to do this by hand is to note that x plus y equals 125. That means you can replace this with 125 in the second equation. And then you can just get y equals 30 because you subtract 125 on both sides. Okay, so that's the correct answer, 30. However, it really doesn't take that much time to go to Desmos. Just graph each line. Right here, 95, 30. We want the y value. It's 30. That's it. All right, question number 3. Here we have basically linear inequality interpretation question. All right, so it tells us the containers, which we use variable C for, cost 187. So that means we're going to need an inequality with 187 times C. And tape, which they use T for, costs 240. So C and D are out. Basically, we're down to A and B, right? Now, he has a total of $15. So now the question is, is it less than or equal to 15 or greater than or equal to 15? So $15 is that's the maximum amount he can spend. In other words, the total amount from buying containers and tape has to be less than or equal to $15. Okay, because that's the ceiling. That's the largest amount. That's all the money he can spend. As compared to B, B is really saying that he has to spend a minimum of $15 on these supplies, and in fact, could spend more than that. But that's not the situation we have, so correct answer is just A. All right, here we have a scatter plot, and there's a line of best fit. They want to know the slope of the line of best fit. So first of all, it's positive, so get rid of these two. They're obviously wrong. Notice it's pretty flat, so it's most likely going to be C, but let's just double check. Go to Desmos. All right, let me just see here. What were the points I wrote down in my notes? I think I used 2, 3, which it's not exactly on 2, 3, but it's close enough. So like 2, 3, which is pretty close to the line, and like 7, 4. Again, they're not exactly on the line, but they're close enough so that it's going to give us, an answer that's very close. So here, notice I get 0.2. Okay, obviously that is closest to 0.22. It's not 2.45. So that's it. That's the answer. I mean, if you wanted to find the slope just by hand using the slope formula, subtracting them, that's fine as well. But correct answer is letter C. Next up, question 5. So on this one, here we have this graph. They want to know about this point. Basically, what's the interpretation of this? All right, so x, the first number, obviously here, first coordinate, 149.02, that's the number of grams per molecule. So we need an answer that has 149.02 grams per molecule. So that eliminates A. A is gone, but okay, now we've got B, C, and D. So the thing is, if you look at C and D, they talk about like a minimum value in C and a maximum value in D, but this point right here is not a minimum or maximum value. Minimum value would be over here, maximum value would be over here. So the correct answer to this one is just B. It's just basically stating the molecular weight is this, and its estimated boiling point is this, and that's it. Next up, basic combinations of function evaluation. So I would just go straight to Desmos to do this. Now, you could do it, of course, by hand or possibly even in your head. That's, fine as well. But I'm just going to type both functions, and then I'm just going to type 7f of 2 minus g of 2. And I get 44. Let me just check my answer sheet. That is the correct answer. Basically, f of 2 turns out to be 8, and then you multiply it by 7, and it's 56. G of 2 turns out to be 12, so it's really 56 minus 12. Letter D. Okay, next, circle question. So, circle A, here in standard form, means that it has 25, the number on the right, equal to r squared. Therefore, r, or the radius, is the square root of that, which is just 5. Circle B, okay, is equal to k, where k is a constant, and we know that the radius is 2 times that. So we take 5 times 2, and we get 10. Then you have to take 10, and you have to square it to get the r squared for circle B, which is going to be 100. So the correct answer for this one is just 100, and that's it. All right, next question. Here you are basically just given a function and want to know what's the x value when the y value is equal to 63. So this, again, now you could do this by hand. You could do this in Desmos. I mean, it's actually not that much work to do by hand because if you notice, divide by 9 first. That gets rid of that, and then it's just minus 3 divided by 2. So x is going to be equal to. However, if we want to do it in Desmos, maybe this one I would want to solve using regression. So I could type 63 equals, or tilde, 9, 2, and now I'd use 2x1 plus 3. Right there, x1 is equal to 2, so that's my answer. So if you want to do it that way, again, perfectly acceptable. Next up, number 9. Okay, here is a question that I would absolutely use Desmos for. Because you have a quadratic equation, you're given one of the solutions, This is a very easy problem to do. All we have to do is type out the left side of the equation equal to f of x. Basically replace 0 with f of x, really. And then I'm going to tell Desmos f of the expression negative 7 plus square root k over 2 tilde 0. Because it's a solution means you plug that number in for x in a quadratic and you get 0 as your output because it's equal to 0 here. So what does k have to equal? Well, right there, k is 29. That's our answer. Now, if you wanted to, of course, you could go through and you could do, quadratic formula. I mean, specifically, you're interested in the part underneath, the discriminant part underneath the radical here, right? It's b squared minus 4ac. So it is 7 squared minus 4 times 1 times 5. It's 49 minus 20, therefore it is 29, and that is your k value. So if you want to do it by hand, that's fine. That's basically the work for it. I would just personally, though, go to Desmos and just type it in like that. All right, next up, here we have some combining like terms. However, you do not have to do this full entire problem. Notice you have three different polynomials being combined here, right? And it tells you that, okay, once you combine everything, you get this right here. All we're concerned with are the x squared terms. So notice, first polynomial, there's no x squared terms. Ignore it. X squared term here, x squared term here. Now, let me just erase this because I think covered up. Notice there is a minus sign here. So it really becomes negative 5x squared and then minus 3x squared. Therefore, you get negative 8x squared. So what is a? A is just negative 8. Therefore, it's answer choice A right here. Now, I will say you could do this in Desmos. I will demonstrate this, although I don't think this is the fastest or most efficient way to do it. But what you would do is type out the whole thing. Let me just expand this. Okay. And now we want to set this equal to 9x1 to the 4th plus x cubed plus ax1 squared minus x1. Okay, now notice it's already giving me the correct answer of negative 8, but technically you should still add the element list. Basically what I'm doing here is this is matching two expressions to find the value of a constant, which in this case is a. So notice here I add in some values to my element list. Yeah, a is negative 8. So this is an alternate way you could do it, but as you can see, it just takes a while to type the whole thing out. So that's probably not the method, that I would use for a problem like this. All right, next up, number 11. Okay, here we have an inequality. It's graphed out, and basically you're told it's of the form ry less than 60, right? What's the value of r? Since this is multiple choice, I would go to Desmos, and I would type ry less than 60. All right, then I would add a slider for r, and I would choose the specific values in the answer choices and see which one matches. So notice when I do this, okay, does this look like what we have here? No. What we have here is the line going through negative 4 and shaded up. This is positive 4 shaded down. Okay, so that's wrong. No, this one, the whole thing is shaded. Not correct. Whole thing is shaded. Okay, looks like it has to be D. And yes, notice this graph here matches the graph in my Desmos window. So the correct answer is this. Now, just to show you why that happens, okay, this is what you have originally, right? And then say you divide by r, so you get y is less than 60 over r. This inequality, if you graph it out, is the same as y is greater than negative 4. So it's like if you look at these two things and try to match them up, you can think about, all right, what does the value of r have to become to make this equal to negative 4? And you know what I mean? In other words, 60 over r equals negative 4. And of cross multiply, and then divide, and you get r equals negative 15, and that also causes the sign to flip, because you're dividing by a negative. Therefore, that just confirms negative 15, correct answer. All right, number 12. Here we have a conditional probability problem. So, all the positive integers less than or equal to 160 are basic. There are 160 of those total. 1 to 160 inclusive. Now, you're choosing from set K, which is a number, which is even and less than or equal to 50. Okay, so from 1 to 50, there are 50 total integers, but half of them are going to be even, just like half of them are going to be odd. Therefore, there are going to be 25 numbers which are even and less than or equal integers less than or equal to 50. So 25 is the number of favorable outcomes. That goes on top. And then this just gets reduced to 5 over 32. So the correct answer is A. And by the way, just to show you if you're not familiar, you can just type in 25 over 160. It'll do the decimal. But then if you click this again, there's the reduced or simplified fraction, the 5 over 32. Next up, you have a histogram question. So this is actually a good question because it makes you think about it a little bit. All right, so you have 50 values here for points that were scored, earned, whatever. I don't know why they use the word earns instead of scores, but regardless. In a game. So there's 50 total things here, right? Then they add this new value of 18, which would be like basically one thing down here at 1 to make a new data set, okay, with this additional value. What's true about the mean and the median? Okay, I'm going to start with the mean first because that one should be much easier to figure out. All the current values are between 30 and 70. So if you add a value of 18, that is obviously going to decrease the mean. That is going to cause the mean number of points per player for dataset B to be less than the mean number for A. So 2 is absolutely true. So basically, get rid of this and get rid of this. It's either 2 is true, 2 only is true, or they are both true. Okay, now, what about the median? What happens with the median values? All right, so when you're looking at this, you're probably thinking, okay, well, this is a histogram. We don't know exactly how the numbers are split up between, 30 and 40, 40 and 50, both 50, 50, so on. So, how can we determine definitively, like, yes, one is true, or no, one is not true? All right, so essentially, the way to think about this problem is this. Dataset A, there are 50 values, okay? Dataset B, there are 51. The median value for the median for dataset A will technically be the average of the 25th and 26th values, okay? The median value for dataset B is technically going to be the 26th value. And the way you get that is you technically take the number of items in the set, you divide it by 2, so 50 divided by 2. If it comes out to a whole number, then that means there are 2 numbers in the middle that you average. So in this case, 25 is a whole number, so we need 25 plus 26. If it comes out as a decimal, like it does here, then what's going to happen is we're going to just round up, and there's going to be that one single middle number because there's an odd number here. All right, so the 25, sorry, this should be 25.5, not 25.2. It's 25.5, and therefore it rounds up to 26. Okay, so now, as you're looking at these values and counting, essentially, if you notice, the 50 to 60 column here has more than 25 values in it. In other words, this has at least 26 values, which means that in dataset A, there are 24 or less values in these other three columns. Therefore, the median is going to have to be between 50 and 60. So in dataset A, the median is going to be somewhere in, like in this thing. Okay, we don't know we don't know exactly where it's going to be, but we know it's going to be between 50 and 60. Then in dataset B, okay, the same thing is essentially going to happen. Like the 26th value is going to be the median value. And again, that is going to occur between the 50 and 60 in the 50 to 60 bar. Another way to think about this or look at this is, okay, there's one value here. Say this is like 4 for the frequency. Just say this is 7, just approximating, you know. It's like 1 plus 4 is 5 plus 7 is 12, okay? Then, when we add in 26 more values, we have now crossed the 26th or median value for B. So it's going to be somewhere in here. Same thing for A. You know, ignore this one, but it's like 4 plus 7 is 11, and then when you add in 26 more, the median is going to be in that 50 to 60 range. So we know that both of them are going to be in here. So is it true that the median number of points per player for B is less than the median number for A? Well, it's impossible to determine that because we don't know the specific breakdown of the values in this range. So it could be true or it could not be true. Therefore, the correct answer to this one is going to be letter B. Like, basically, we don't know how the 26 numbers between 50 and 59 are broken down. So, therefore, without knowing that information, we can't determine exactly which value is the median value, like for B, or which two values we average to get the median for A. So therefore, correct answer for this one has to be letter B. All right, next. Here we have basically a proportions problem. So we essentially know that like 1 inch in the scale, so I'm going to put the scale on top, is equal to 17 over 3 feet in the actual. And then it tells us if the length in the actual is x, how long would this be? Basically, these expressions are like how long this would be on the scale, y inches. So if you notice here, basically you want to solve this proportion for y, for this top right. I mean, you could put whatever letter thing you want here. So that just means you're going to multiply both sides by x. Notice here the feet and the feet cancel out. So you get, okay, the y inches, the inches for this actual measurement of x feet. It's x on top, because x times 1 is just x, and then it's divided by 17 thirds. But when you divide x by 17 thirds, what actually happens is the 3 comes into the numerator and the 17 stays in the denominator. So the correct answer for this one is just going to be letter C. It's going to be 3x over 17. Now, I will tell you, another way to figure this out would be to use picking numbers. And so what I would say, and this is how I would do it. 1 inch to 17 over 3 feet. Let's say that x is equal to 17. So in other words, the actual distance is 17. And how many, and now I'm going to put, I'll just use y just to avoid confusion with this x. How many inches is that equal to in the building? On the scale model. Okay, so if we want to solve this, well, you just multiply by 17. All right, so now we go through, and so we have 17 here divided by 17 thirds. Again, if you're not sure what that is, just go to Desmos. And just do 17 divided by 17 thirds. And notice it actually comes out to 3. The 17s cancel, and the 3 actually gets divided to the top. So, for these numbers, so when x is 17, y is equal to 3. So now we go through all the answer choices, and you plug in x, 17 for x. So 3 times 17 over 17 times 12. And we're looking for an output answer of 3. Okay, in A, we do not get that. So now let's do B, where we switch 17 to 3 top to bottom. No, not correct. Let's look at, notice in C, we do get the 3 value that we're looking for as the output. That's because that's the correct answer. And of course, if I do letter D, okay, clearly not correct. So that's just a way you could do this using picking numbers, where you pick an actual numerical value for x if it's easier to think of it that way. All right, next up, let's look at this question, and I am going to go straight to Desmos to solve this initially. And all we have to do here is set up a system of equations. So the first equation is going to be the cube root of p squared. Okay, that is equal to t to the 9/7. Okay, so that's equation 1. Second equation, t is equal to p to the 3n. Now I have to type it like this, because if I tried to type the -1 after the n initially, it'll go down back to the main level. Okay, so notice what's happening here is it's not quite working out correctly, because it's just defaulting to p and t are 1, and therefore it wants to know, and therefore it's just making n 1. But notice it says in the problem p is greater than 1, t is greater than 1. Okay, so these values are not acceptable. So let's just make p 1.5. Okay, now is t greater than 1? Yes. What's my n value? Well, looks like some random decimal, but if I click this, it's 41 over 81. So it looks like, so that is my correct answer. You could also technically type in, I guess there's a bunch of different ways to do this. 0.506, 0.5061, 0.5062, because you can truncate it or round it. But so either of these three would be acceptable as well. That's how you can do this entire problem in Desmos. Now, I will also mention, if you want to do this by hand, let me see here. How did I... Okay, I substituted. So I took the original equation here. First, I rewrote the left side as p to the 2/3. Then, on the right side, in place of t, I put p to the 3n minus 1. Now, basically what you're doing is you're equating the exponents. So, easiest way that I chose to do this was basically raise both sides to the 7/9 power. And because that then gave me p to the 3n minus 1. And over here, I got, what was it, 14 over 27, I think. Now you can set the exponents equal. 14 over 27 equals 3n minus 1, because the bases are equal. Well, they were originally, but I just think it's easier to set up this equation and then add 1. This, again, you can do all this work in Desmos. 1 is just 27 over 27, so it's 41 over 27. And then when you divide by 3, this is going to become 41 over 81, because the 3 ends up multiplying by the 27. But again, those arithmetic calculations, just go to Desmos and do them in there. Or even once you get to like this point, like if you want to do it by hand, say you don't want to do system equations. Once you get to this point, all you have to do is just go to Desmos and say, okay, 2/3 and use regression is equal to 3n plus 1 times 9 over 7. Okay, what? Oh, it's minus 1, not plus 1. I'm misreading my handwriting. There we go. Yeah, that's minus 1, not plus 1. Right there. Get the same n value, 41 over 81, and that's it. Okay, so that's how you can solve this problem. All right, next up. Here we have another problem where I'm going to go straight to Desmos initially, and then I'll talk about and show how you could solve this by hand. So, you have a rational function here, and notice it has two constants. However, we fortunately are given 2 points. One point is 0, 22. Second point, negative 22, 0. Now all I have to do is type in the general form minus x1 minus a, x1 cubed minus x minus b. Oh, forgot the 1. Okay, notice it finds the value of a, which we don't need. It finds the value of b, which is 23, and that's it. Correct answer is A. You don't have to do any more work. All right, now I will say, though, here's if you wanted to like solve this by hand, basically what you would have to plug in first is this point right here. Because if you start with 0, 22, you're going to get 22 equals negative a over negative b, or just a over b. But you can't solve that for a or b. So if you start with the second one, though, 0 equals, and like, yes, technically you're plugging in negative 22 on the bottom, but they're all going to cancel out. Negative 22 squared minus 22 minus a. Because if you go to cross multiply this, you're going to have 0 times this whole thing, and that's still just 0. All right, so on the top, this is a, by the way, 9. You've got 0 equals, what is it, negative, 22 squared, which is 484, minus 22 minus a, minus negative 22 plus 22 plus a. This is going to be 506. A equals 506. I think that's what we had up here. Let me just go back. Yep, A is 506. So that checks. Then you can plug in the second thing, and basically, like, it's going to be 0 minus 506 over 0 minus b equals 22. 22 equals 506 over b. They're both negative. Like, this all drops out. They're both negative, so they become positive. B equals 506 over 22. And that should be 23, which is the correct answer. So this is just the work if you want to do it by hand, but you can see it's so much faster just to do it in Desmos. All right, next up, question number 17. For this problem, I think it's so much easier to do the method of picking numbers where you let x equal a number. Let me just check. Just trying to check my work here, see if I wrote down which number I let it equal. I think, oh, it's down here. Yes. I let x equal 20. Therefore, the original angle that you have at this intersection, so like say here are the things that are intersecting, right? Okay, the 9x minus 40 is one of these angles. We don't know which one it was, it doesn't matter. But the point is, say like this is 40, and that means the one next to it has to be 140. And the one across from it's 40, and the one over here is obviously next to it still on the other side, still 40. So the reason I do that is now I say, okay, what are all the different pairs of like two angles together that we can make? Well, obviously two adjacent ones form a straight line, that's 180. These two vertical angles will be 80, and these two vertical angles will be 280. So now I just go through the answer choices, and okay, D is obviously out. I already see 180, 180. But I got to look at A, B, and C to see which one does not equal, the remaining values. Okay, the first one equals negative 80, so that's probably the correct answer to the problem. Second one equals 280, which matches, and the third one equals, forgot the x1 subscript, there we go, third one equals 80, so that one matches. So the correct answer to this one, i.e., which one cannot be the sum of measure of any two angles, is A, negative 18x plus 280. Now, where they're actually getting these expressions from, just to show you real quick, it's like this is the 9x minus 140. This is 9x minus 140. Here, it's just 180 minus that. So when you simplify that, it becomes negative 9x, and then this becomes plus 140, so it technically becomes negative 9x plus 320. And this is negative 9x plus 320. So now you just do the same thing I did in the others, except you're just adding expressions instead of adding numbers, right? Like these two together obviously add up to 180, so that's, that's one you can make. Here, negative 9 is negative 18. 320, 320 is 640. So that's basically this one. That eliminates that one. And then across here, 9x plus 9x is 18x. Negative 140 is negative 280. So that eliminates that one. So that's where the actual expressions themselves are coming from. All right, next up, question number 18. Spoiler alert, this is a direct copy from practice test number 6. Everything about this question is the same. The only thing that's different is they changed one of the numbers, which is very disappointing and extremely lazy, in my opinion. Anyways, YQ is 21, WQ is 70, WX is 60, XQ is 120. What is YZ? I'll call this X. These two triangles are similar because they have two pairs of congruent angles. This is the first pair, and the second pair are the vertical angles here. So by the AA similarity postulate, we have similar triangles. So let's match up the corresponding parts. 21 over 70 equals X, or YZ, over 60. So this is the equation you set up, and then just go ahead, cross multiply this, solve it out. Personally, I'd just go to Desmos and do 21 divided by 70, and I'd probably use regression. Okay, X is equal to 18, and that's the correct answer. And that's it. No more work that's needed for this problem. All right, next up. For this problem, I would go straight to Desmos. It's just so much faster to just graph it out and see which of the two possible lines will intersect the original at least once, i.e. at least one solution. So, all right, let's make sure here. Oh, I didn't type it right. This is a 7. There we go. Notice these are overlapping completely. I turn the blue off. Green is there. Turn the blue on. Green disappears. So basically, these two overlap completely, or in other words, this system with this line and number 1 are the solution to that is infinite solutions. Basically, this number 1, everything is a multiple of 1.5 times the first one. It's like 2 times 1.5 is 3, 9 times 1.5 is 13.5, 7 times 1.5, 10.5. But you don't need to necessarily know that. You can just look at the graph and see it overlaps it completely. Therefore, there is at least one solution. So 1 is going to be in our answer. So get rid of this, get rid of this. And then in the second one, if we just check this. Okay, now looking at the original line and this one, these two have different slopes. Okay, this one's going to have a negative slope. This one's going to have a positive slope. Therefore, they are guaranteed to intersect because their slopes are different. The only way two lines will not have at least one solution is if there are no solutions, and of course that's when the slopes are the same and they have different y-intercepts. In any case, both of these are going to have at least one solution. Therefore, the correct answer to this problem is just letter C. All right, next up, question number 20. Here we have a right rectangular prism. Let me just sketch this out. Okay, ignore that terrible drawing. Base area is 24t. Length of the base, 8/3. So 8/3, I call that x. Height, 15. What's the expression for the total surface area of this rectangular prism? All right, so first thing we have to do is we have to take 8/3 the length times x, the width, and set that equal to 24t, because the area of this thing right here is 24t. The reason we do that is so we can get an expression for the width in terms of t, because all the answer choices are in terms of t. So you just multiply by 3/8, or technically divide by 8/3, however you want to think about it. 8 into 24, 3 times 3 times 3, it should be 9t. So this is going to be 9t. So now we're just going to go through and we're going to add up, the various surface area from the various faces. So the top and the bottom are bases, and we already know that the total area is 24t. So we need 2 because there's both a top and a bottom, and then 24t. And then let's do 2 times the surface area of the left and right side. So that would be like this face and this face. And the two sides that form these are 9t and also 15, the height. And then we've got the front and the back. So, and there's 2 of them, 2 times 8/3, and then times the height 15 again. So now if we go through and multiply this all out, on the front here we have 48t. Here, what is this simplified to? I think it's 200. It should be 270t. Yeah, 2 times 15 is 30. 30 times 9, 270t. And then over here, 3 goes into 15 5 times. 40 times 2 should be 80. So now these, of course, can be combined. So I get, let's see here, 318t plus 80. Correct answer for this should be letter B. Now, I will say an alternate approach you could take to this is you could pick a number for t, like whatever, let t equal whatever, 2, and then solve the whole problem out using all numerical values instead of actual expressions. The only reason to do that is because if you think it's easier to work with straight numerical values instead of like these expressions with t. And then you're going to go through and you're going to work it out and you're going to get some number for the total surface area, and then you go to the answer choices and you plug that t value in to each of them and you see which one equals the same value that you got. So that's another like alternate approach you could take as well. All right, next up, here we have a polynomial. Basically, this looks like a difficult question, but it actually is not. It's actually relatively easy. So what's going on here is you have this graph, this original function, okay, here. And if you want to write it in intercept form, it's going to be something like this, something like this. Okay. So notice there are 3 zeros here. There's a 0 at -2, and that one crosses, which means that's the quote-unquote like c here. That's the parenthesis without the squared. So that would be x minus -2, or technically x plus 2. And then we've got it bouncing at 1 and 3. A versus B, it doesn't matter, but it's going to be like x minus 1 and x minus 3. Okay? So this is what the original function looks like. Now you're doing a translation to the left 28 units. So just replace the x with x plus 28. X plus 28. X plus 28. X plus 28. Okay, now you end up with x plus 27 squared, x plus 25 squared, x plus 30. Okay, so first of all, I said A, B, and C are here, and for A versus B, there's no difference. So a couple things. First of all, B is going to come from one of these two. Okay, we can ignore this one. And second, notice in the form here, they want it as x minus a number. These are both x plus a number, which means you technically have to rewrite it as x minus -27, or x minus -25. Therefore, now, like, this number could be basically either of these numbers could be your b value, like one is a and one is b. We don't know which one's which. So we look at the answer choices and see, okay, the only thing that we see here is letter D, negative 25. All right. Now, obviously, another alternate way to think about this, and you might find this like quicker, faster, easier, it's totally fine, is, okay, right now you're at these points, right? Then you shift left 28 units. So negative 2 goes to negative 30. Positive 1 goes to negative 27. Positive 3 goes to negative 25. Okay? And remember, when you write like a factor of something, it's always x minus, like say c, well, or whatever, we won't use c here, x minus some number, and that number is your x-intercept value. So the point is, it could be this or it could be this, because these are the only two that touch. Okay, B is one of the ones that is squared, which means it's going to be touching, not crossing the graph. So you take 1 and 3, you shift them each left to the left 28 units. Well, you're at now negative 27 and negative 25. So those are your possible answers, and of course negative 25 is the only one that we see. All right, last question. This is just a basic, percentage question, what I call advanced percentage question. We can just easily solve this in Desmos. So let's go ahead and do that. So equation 1. A is equal to what? 468% of B. Okay, then we also are told that A is equal to 0.780% of C. Scroll this over. We are also told that the weight of C is, meaning equal to, P% of B. All right, it automatically fills in values for A, B, and C, and then it calculates P and gives us our correct answer, which is 60,000. And that's it. Don't need to do any more work. You don't need to pick numbers for A, B, or C. It'll do that automatically for you. And everything basically works out, and that's it. That's the answer. Now, if you do want more work or more information on solving these advanced formula problems like this, please check out my Ultimate Desmos Guide to Digital SAT Math. I will post a thumbnail on the screen showing the specific video which goes through how to solve these problems. Alright, so I hope you enjoyed this video going through Bluebook Practice Test 11, Module 2B, the harder of the 2 second math modules. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have questions or comments or any alternate solution methods, please feel free to leave them below as well. Also, if you haven't done so already, check out the full solutions and explanations to Module 1 and also Module 2A, the easier of the 2 second math modules from the same practice test number 11. And in addition to that, check out the first look that I did for Module 1 and for this same Module 2B. Basically, working through the test, in real time for the first time as I've seen any of the problems on it. So check out that video if you want more information on the timing and how to complete the test within the allotted 35 minutes. And lastly, if you're looking to improve your knowledge of Desmos, please do check out my Ultimate Desmos Guide to Digital SAT Math. It's over 7 hours now of tips and tricks, and we're up to 73 total practice problems to help you ace the digital SAT math section.